Good morning. It's the first day of fall. Today is September 22nd, and this year, that is the first day of fall. It's called the fall equinox, or the autumnal or autumn equinox. It's the day when the length of the day, light hours, and the length of the nighttime hours are equal, 12 and 12. In the summer, the days are longer, and the nights are short. In the winter, the days are short, the nights are long. That's why it gets cold in the winter, because there's not enough sun. So you know how in the summer it stays light outside till almost 9 o'clock? Now already it's getting dark by 7:30 these days, and before you know it, when it's winter, it'll be getting dark at 5. And we're getting up in the summer, if you get up around 6 o'clock, you're getting up in the daylight. In the winter, you'll not have to get up in the dark. I hate it. But it is what it is. So we're going to talk a little bit about why that happens, because of how the sun and the earth interact. Now in our science book, it talks about this also, but this is for geography. So we're going to be looking at this page, geography number 3. I'm going to go get our globe. I'll be right back. Hey, okay, here's our globe. So, I suppose you probably noticed that every globe in the whole world is sitting on a stand like this. It's not crooked because the stand is broken. It's not supposed to be straight up, but it ends up crooked. It's supposed to be like this, because this is how the earth is in space compared to the sun. It has an angle, a tilt, of 23.5 degrees. So there's a question on here that asks, right in the middle there where my finger's pointing, what is the angle of the Earth's axis? The axis is this stick. It's not really there, this imaginary stick that goes through the middle of the Earth. 23.5 degrees. God is so smart, he knew exactly that it needed to be 23.5, not 20, not 25, exactly 23.5. So let's try to understand why we have summer and why we have winter. So in the winter, turn the globe around until we see North America. Here's North America. In the winter, the sun is over here, and as we come around to face the sun is over here. It's shining on the earth, but it's kind of at a low angle. It's hitting us kind of like that. But then as we go around the sun, I'm going to come back to the same spot because I can't go around the sun and still be in the video. But now, when the North America comes around, it's facing, if this is still the sun, whoops, here's North America. Look what it's doing now. The sun shines right straight at it and heats it up a lot more. So that's what this picture on your paper is explaining. On this side, the sun, if we live at the X is a little north of us, but that's about where we are. In the winter, the sun is hitting, kind of almost skipping over the top of the earth on this part, and it's hitting straight on down here. So this is winter. So why don't you write that up here, winter. Then we go around the sun half a year. Now we're on this side of the sun, and here we are still, but now look at the sun shining straight at us, and it's hitting the south part of the earth at kind of a flat angle. So that's when it's hot, is in the summer. So write summer, that's when it's hot, when the sun is hitting us more straight on. And the sun is much more straight overhead in the middle of the day in the summer. In the winter, the sun is very low down in the sky. And so the rays of the sun hit us much less, and so it gets cooler. Plus, because the nights are so much longer, your book talks about this, that At night, we lose heat from the Earth out into space, and in the day, we gain heat from the sun. So let's go over to the board, and I'm going to show you this on the board. So, in the summer, the days are long, almost 15 hours. So how many hours are left of the 24 for nighttime? Only 9. This is day, and this is night. So this is summer. In the winter, same 24 hours from here to here, but now the day is only about 9 hours, and the night is 15 hours. So it gets hot in the summer because we have lots of daytime and not a long time to cool off at night. In the winter, this is day, we don't have very long to warm up, and then at night we lose heat out into space. And so it keeps cool. That's one reason. The other reason is the angle of the light, like I was just saying. So here's the Earth. And the sun's rays are coming in. And the sun, when you're a little kid and you draw a picture, you draw a sun like this. Right? With the rays coming out like that. But actually the sun is so big and it's so far away that by the time the rays get here, they're running parallel. They're just running like this. All the same. But the Earth is tilted 23.5 degrees. If you didn't write that down yet, write it down now. 23.5 degrees. So when we are in the winter time, the Earth is tilted like it's drawn here. So where we live up here, the light is hitting kind of flat. So we took this and turned it, so this is the ground now. The light's coming in kind of like that. We took this line right here, and we brought it down here. So we have this kind of an angle right here. Now, when the sun goes around the Earth, the sun goes around the Earth. When the Earth goes around the sun for a whole half a year, now it's on the other side. So now we're over here. Same sunshine shining on us. But now, if you take this line and you turn it, the sun is coming almost straight down. So we're getting a lot more sun hitting us because it's more powerful coming straight down than coming in at a low angle like it does over here. You can do an experiment if you would like with this. Take 2 pieces of paper, black paper, dark colored paper, set one of them flat on the ground and set the other one kind of at an angle. Maybe prop it up with something underneath it like a block of wood or a rock, and leave them both out in the sun and see. I tilt this one up quite a bit and then leave it out there for about 10 minutes and see which one's hotter to the touch after that. This one should be hotter because it's getting more sun hitting it straight down than at an angle. Because if the rays are coming down the same distance apart, but they're coming more in at an angle like that, whoops. This is a bigger space right here than it is right here. So this is winter, and over there is summer, where we live. Now down here, where the sun is hitting more at an angle, that's the southern hemisphere, like down where Australia is. So at Christmas in Australia, it's the middle of summer. Pretty weird, huh? And June is the middle of winter for them. So if you ever go live in Australia, you're going to be all confused. That's why we get the seasons. So if you look at the drawing, it shows you the same thing. Here the angle is very small. Here the angle is more straight on. This is summer. This is winter. There's a little person who lives where the X is, which is just about where California, north part of California is. And then here's a drawing of the Earth on its 23.5-degree axis. The tilt. If we didn't have the tilt, we wouldn't have seasons. It would always be super cold at the poles and always be super hot at the equator, and we would never have any seasons. Nothing would ever change. And we wouldn't have life that we know it. It would be too hot in some places and too cold in other places. So God, again, in his wisdom, knew exactly what he was doing in putting the Earth on the tilt and then having the Earth go around the sun. Every year it comes back, goes around. It takes 365 days for it to go around the sun and come back. And every year when it comes back, it's on almost the same date. It's the beginning of summer and the beginning of fall, beginning of winter and the beginning of spring. So because today is the beginning of fall, set a timer on your watch or your phone, or ask your mom to set a timer on her phone to go outside and watch the sun go down. Because this is the one of 2 days out of the year when the sun goes down exactly in the west, exactly. So if you go outside right before the sun goes down and you stand out in the middle of a road, don't get run over, get your mom's permission or your dad's permission, or drag everybody in the family out there with you. Go stand out in the middle of the road and look toward the direction that the sun's going down. Don't look at the sun. Never, never look at the sun. It will permanently ruin your eyes. You'll have blind spots in your vision that are all blurry, and you'll never be able to see in those spots. And if that blurry spot is right in front of your eyes, you're not going to be able to read. You're not going to be able to drive. Never, never look at the sun. But you can go out there and wait till it's all the way to the ground and then look. And it won't be to the north and it won't be to the south. It'll be straight out at the end of the road. It'll look like the sun's going down in the middle of the end of the road. And find a road that runs east and west toward the sunset, that doesn't have a lot of buildings in the way, so you can see to the horizon and you can watch the sun go down in the middle of the road.